Hello, I'm Marco and I walk you through the telemetry briefing today. I start with an overview and introduction of the telemetry components, then I show you how you can install it in your vehicle. We go through some mounting guidelines, I show you how to do the self-test, and then finally we look at some telemetry race procedures. Telemetry is all about transporting data from one location to the other. In our case, it is a vehicle that is on track and that is equipped with an onboard computer, or in short, OBC. This OBC sends data to an OBC to an IoT server and receives data back from the IoT server. The telemetry system consists of several building blocks. So we have the pod that is on top of the vehicle and connects the vehicle to the internet, has the usual antennas. It is connected to a backbone that is located in the engine compartment and acts as a hub to a variety of sensors depending on your energy type. The backbone also includes a shutdown relay that can stop the propulsion of your car, and the whole telemetry system is supplied by its own battery. Most of the teams install the telemetry system behind the firewall, and this is also what we recommend. We also recommend to place it far away from electronic troublemakers such as ignition coils, inverters, any power electronics, you name it. If you want to install it this way, where you have, for example, the backbone in the driver's compartment, you could do so. However, we don't recommend it, but please check with the telemetry team. Now let's start with an overview and how we can integrate the telemetry into your vehicle. And I actually use the structure of our checklist here. So this means we share this checklist, and you can take that, go out into the paddock, and when you install your telemetry system step by step and you know the how and the why, you will do so correctly. And when you come back into the tech inspection and we do the telemetry inspection, we use the same checklist, your chances are likely that you pass first time. The checklist is divided into two sections. One is more a generic section that can be applied to all the energies and energy types, and the other is a more energy specific section. Let's move now into the generic part, and let's start with the OBC pod. The pod is on top of the vehicle. It comes with a 4G antenna, GPS and Wi-Fi antenna. When you mount them, please do so gently. Make sure that especially the GPS antenna has a clear view to the sky of about 90 degrees. And also make sure that the pod is facing driving direction, and that when you place it on the vehicle's body, that it is within 20 degrees plus minus of pitch and roll. 20 degrees. So here we see an example that is not so good, because we don't have a clear view to the sky of 90 degrees. It is obstructed by this steep wall of the vehicle. This is a good example because we have a clear view to the sky, it is facing driving direction, and it is placed on a non-removable part of the body. This is what we generally recommend, so you mount it there and it stays there the whole week. I want to pay attention to these fragile pins here, to this connector. As you can see, they are pretty small, so when you in the paddock you have screwdrivers around, just be careful, and just in case if one pin breaks or bends, or if you see something like this, like a cable is pulled out and it's clearly damaged, no worries, you bring it to the telemetry station and we replace the damaged part for you. Now let's move on to the backbone. The backbone is installed inside the engine compartment, and it comes with a cable and a clamping mechanism. So the clamping mechanism works like this. You can rotate, and you can see it's kind of a spring load function. You can push, you can release, you push, rotate, and now the spring load function is charged. What you do now is you move the shaft through the hole in the body. You add a foam pad, and then there is a mounting plate with the 4 magnets, and make sure they look upwards. You slide in the mounting plate like this, you pull back the shaft and you rotate back, and as you can see, The clamping mechanism kind of pulls the mounting plate against the car's body. Now all we need to do is we need to fasten this connector here, the pod connector, and that's it. As you can see, there's no moving around of the pod. The maglets make sure it stays in place. One important thing, when you place the backbone, make sure that you're able to lift the pod so that you can put at least a fist underneath. This is the reason for this is because sometimes you have to exchange the pod, and this would not be able if you could only lift it for this small height. Let's move on to the battery. The battery lasts for about 4 hours when it's fully charged. Fully charged means it has 5 bars. 5 bars is 100%. We need to have at least 3 bars when you go out on track. So 3 bars is 60%. 2 bars, for example, would be 40%. Then you need to recharge. One warning, when the charge is too low, a red light will be flashing here. And this means you will be delayed to go out on track. So then we have the battery holder. You slide in the battery into the battery holder. You mount it like this, but not like that. This is also okay. And you can charge the battery with a supplied power supply, like this. And then you plug in the jack into the backbone where it says power. So this would not be acceptable. A team used tape in order to make sure the battery will not move, but in that case we could not replace a battery, for example, that is too low. So don't do this. Please also don't use zip ties around here. This is also a nice example on horizontal installation, works very well. You always need to make sure that you can exchange the battery at any time and it doesn't fall off. Again, just because it's so important, 2 bars, you are not allowed to go on track. You need at least to have 3 bars. However, I would recommend that you go out fully charged. Then you don't have to worry about what's happening in the battery. The shutdown relay is something that stops the propulsion of your car, that is used in the championship. And although it's a pretty simple device, actually, it always raises a lot of questions because now we kind of combine the standard of the telemetry system with the individual solutions in your engine compartment, and everybody has a different powertrain. So I'll tell you what it does. There's a relay and it comes with a normally open and normally closed contact. So these are 2 potential free contacts that you need to wire with your motor controller just the way it works so that you can stop the propulsion of the car. Normally closed means when you find the relay is opened and the motor should stop. Normally open means when the relay is fired, the relay is closed and the motor should stop. This is how it works. Just one warning, you are not allowed to use the e-stop. So I show you some alternative ways to wire your relay. Let's start with the battery electric and hydrogen, because they have a motor controller for sure. For example, we have an enable input, so we use a normally closed relay and pull the signal to the system voltage. Or you can use disable negative and pull it to ground with a normally open contact. So in either case, when the relay fires, the motor stops. Or you can use the speed input and disconnect it with a normally closed relay and then use a pull-down resistor. So this is one example. Let's move on to the internal combustion engine. Some ECUs, they also have an enable and disable negative. However, if you don't have that, you can use the dead man switch. And this is a pretty tricky part and really easy to install. So in series with the dead man switch, you wire the normally closed relay. So either if your driver pulls off the hand, or if this relay fires, the motor stops. So this is also generally recommended for battery electric and the hydrogen. In any case, you must ensure that you only use instrumental current through the relay, which is a maximum of 1 ampere. And with ICE, it is not allowed to use the ignition coil. So these are some examples. If you are not sure, if you have questions, you can always come to the help desk and we help you. And we also know it's pretty mind-boggling. You know, there is normally open, normally closed, and negative and positive logic. This is why we supply a test board for you. So before you plug this into the backbone, you can plug it into the test board, and when it's on run, the motor runs. When you flick it to stop, the motor stops. So what you actually do, you're mimicking the relay that is inside the backbone. And when this works, you are all set. You can plug that connector into the backbone and relay is checked off. So now this has been the generic part of the checklist. Now let's move into the energy specific part, and I want to start with the joule meter. The joule meter, as it says, it's this device here. It measures electrical energy, converts it into joules, and it is placed, for example, between a battery and a powertrain. So energy flows through these terminals here. We have input and output, negative and positive, which is pretty straightforward. And then we have a button. We can switch it on, we can switch it off. When we switch it on, we see here this is a status LED that must be green. If it's not green, you check with the telemetry team. And the upper LED is a level indicator, so when it's green, it's fully charged. When it's amber, it's still okay. When it's red, then you bring it back. The battery needs to be replaced. When you install the joule meter, make sure that the buttons is accessible and the LEDs are visible. And then we can connect it through the CAN cable to the backbone where it says sensor. This is what I do here. Done. And what you see here is already the configuration for a battery electric vehicle whose schematics we can see here. So the joule meter is placed right after the horn and close as possible to the battery. Then all the energy is measured, or the non-propulsion energy such as the lights and of course what you need in the motor controller. And as you can see here, this team uses normally close contact to shut down the car, to shut down the propulsion. This is a battery electric example. If you want to know more, check out this QR code. And the joule meter is used in all energy types. When we move on to, and this is the how the battery electric telemetry system looks like. We have the pod, we have the backbone, we have the battery holder, the battery, the relay, we have the joule meter, and of course the cables. And when this kit is installed in the vehicle, it looks like this. Battery, joule meter, backbone. Or in another example again, battery, joule meter, backbone. When we move on to the internal combustion engine now, we need another sensor, which is the liquid flow meter. That's this guy here. The liquid flow meter must be installed in a way that it is on the lowest part of the fuel system, so well below the fuel tank, well below the fuel injector. And please ensure that there is an isolation between the car's chassis and the sensor. Some tape will do. And this is the schematics, how it looks like. So we have the liquid flow meter is connected to the backbone the same way as the joule meter is. We use a CAN cable here, and because we have two sensors now, we use a T-splitter. This is how the T-splitter looks like. So the T-splitter also connects to the joule meter that measures the electrical energy of the internal combustion vehicle. This means like the lights, the wipers and so forth. So we place it right after the horn, but before the starter. And again, this team used the normally close contact in order to stop the propulsion of the car in case the relay fires. This is how the internal combustion engine sensor kit looks like. So we have the liquid flow meter, the T-splitter and the joule meter and the cable, and this connector here will be attached in the same position like we did with the joule meter. It is the connector where it says sensor. And this is how the installation looks like in a vehicle. We have the joule meter, we have the liquid flow meter, and you can see the T-splitter here. Another example, T-splitter, liquid flow meter, backbone. Another example. So last but not least, let's move on to the hydrogen vehicle. We need a gas flow sensor here to measure the consumption of the fuel cell. And this device is connected to our OPC backbone with a D-sub-9 cable. So you see here, this is the sensor, this is the cable. And this is how the schematic looks like. It's a little bit busier than the other two. Here we have the gas flow meter as the main sensor connected to the D-sub-9 connector here. Then we have the joule meter measuring the electrical energy, such as the lights, the wipers, and so forth, is placed after the horn. And on the same CAN bus is also another joule meter that measures the energy of the supercapacitor, and that's why we also need another T-splitter here. We have again the normally closed contact relay that is used to shut down the car in case the relay is fired. And this is how the typical sensor kit looks like. So we have one joule meter for the electrical energy, another for the supercap, we have the cables, we have the T-splitter, and this one will be attached where it says sensor. And this is how an installation looks like: the gas flow meter, the D-sub-9 cable, the supercapacitor joule meter, the T-splitter here, and the joule meter for the electrical energy. Another example. And now we have covered the energy specific types. Now let's go into the cabling. So first of all, it's very important that everything you see here on the table, which is the telemetry system, should not be in electrical isolation, must be in electrical isolation towards the vehicle body and the vehicle chassis. And it must stay away from electrical fields. So in order to do that, one trick is that we fully isolate the mounting hole where we place the OPC pod. So we put tape on top, on the bottom, and also in between, so that we have fully isolated situation here. There is no chance that the OPC pod is connected to the body. And then finally, what we do at telemetry inspection, that's why I already tell you how we do it. We use an ohm meter here, a multimeter. So one probe we put at the ground of the telemetry system, which is the ground, the last pin at the power of the backbone. And the other probe we put on the body, we put on the chassis, and then the minus pin of the joule meter. And the value must be larger than 100 kilo ohms of resistance. If it's larger than 100 kilo ohms, we are fine. If you don't achieve that, please check with us at the telemetry team. Some rules now, or more guidelines: don't use loops. So a loop always will pick up noise from the environment, so they act like antennas. So what we must ensure that there is no area. So what we can do is we can kind of wind them up and then make them flat. Like you see here, flat cable, flat cable, flat cable, so there is no chance that electrical noise is picked up by the telemetry system. Second, make sure that the cables are mounted securely, that they are far away from electronic troublemakers or from chains, and they are fastened, that you can use zip ties here. So you need to make sure that the cables will not move, and then I don't want to see any dangling cables in your engine compartment. Another guideline is that you use strain reliefs whenever possible. One is, for example, here, where you have the strong CAN cable will help the weak power cable, and just use a zip tie here and the strain is relieved. Very important is the connectors. You can see here the CAN cable comes with the so-called M12 connectors. So when you do the turning, there is a certain point when you are sure the connection is established, and this is the certain click at the end. So you need to do a click here, a click there, a click here, and then we need this click to make sure it's fully connected mechanically and electrically. And now we are done. We have installed everything as we wanted. We can now do a self-check. A self-check means we can turn on the telemetry system, which means switching on the OPC pod and switching on the joule meter. This is what we call switch on the telemetry system. Now we have to wait 60 seconds. It takes some time to boot, and then we are able to do a check. And the check means we need to have a really stable LED configuration here. So for example, in that case, the amber light is blinking, and in 99% of the cases we forgot to switch on the joule meter. And you can see when the joule meter is switched on, it goes back to a steady light, and this is what we want. We want to have steady lights, then we are sure the OPC is working correctly. So this is what you can test already in the paddock. And make sure that you check off all the boxes, that you don't forget one step. Every step is important. To put your signature, date and name here, your responsibility that you did everything right, and you check also for a steady light, and at that time, in this situation, you are ready to go to the telemetry inspection. Let's review what we have done, what we have covered. We looked at how to install the pod, how to install the backbone, how to wire the cables, use strain reliefs, secure mounting. We looked at the battery, 60%, and the resistance or the isolation between the telemetry system and the car's vehicle body and chassis, 100 kilo ohms. This is important. So now let's cover some race processes that are specific to the telemetry system. So let's say you are in the paddock and you intend to go out. Either you want to do a practice run or you want to do an attempt in the competition. Please switch on the telemetry already in the paddock. It takes some time to boot and to connect to the GPS, and so make sure that you have 60% charge. You switch on the telemetry system, means switch on the pod, switch on the joule meter, and that you have a steady amber light. Then you move to the start area, you cross the start line, you do your laps. When you cross the finish line, don't switch off the telemetry system, because now we want to upload the data for later use. So you switch off the telemetry system when you're back in the paddock. Switching off means you press here for 5 seconds and you switch off the joule meter. And in this state it will be if you are not out on track. It is switched off to save battery. So now if you want to make a deeper dive into the components, or if you want to download STL files, check out the telemetry wiki. Here's the URL, here's the QR code. It brings you to the telemetry wiki. It will be updated throughout the year, so don't lose the code. And then at that moment you are ready to attend the second step of the telemetry briefing. It is filling out a questionnaire. This is confirms your attendance. There are a couple of questions with very detailed answers that are required, but it shows us that you have understood everything. And then you go to the help desk, and in the help desk we again make some last checks, ask some questions, maybe answer some questions from your side, and then you receive your telemetry kit. You go out into the paddock and install it in your vehicle based on the checklist that you receive. And then I want to make you aware of the data and telemetry bootcamp that also happens this year. It comes in 2 parts. In the first part I will show you how to pick the low-hanging fruits, like with data dashboarding and MVP philosophy. And in the second part we move into holistic data racing, and we use the building blocks of AI there. And just in case you want to use the data, your manager received the credentials so that you can access the data. And yeah, that's it. Then after every attempt the data will be available, and here in this bootcamp I show you how to use it. So we are at the end of this briefing. I guess we see each other at the help desk, and then the tech, and I expect a steady light. Good luck on the track. Bye bye.